So we have one person for to increase mechanical advantage, and that's 6 plus 5, which is 11. 4 to decrease the force applied over a longer displacement, and we have 3 to make life easier. Which one do we know is definitely not right? That was just in there for the funsies of it.
C, to make life
easier. C, that was just for fun, so you know that wasn't right. And a lot of you guys put B. B got 11 choice things. Why did you guys choose B?
Because it's the right answer.
It's the right answer.
And plus you taught us.
It was in the notes yesterday.
It's what Miss Crane taught me.
Yes, keyword is in the notes. It's awesome. That's what Miss Crane taught me. It's great too. Technically, to decrease the force applied over a longer distance, that's kind of the definition. Oh, not kind of. That is the definition of a simple machine. And to increase mechanical advantage is kind of a byproduct of that. So, increased mechanical advantage, why we want it, sort of a byproduct that we have after doing these simple machines. So, segueing, that was kind of the review from what we did yesterday. Why don't you guys get your homework? Anyone have any questions over a problem or something? If you're not home with it, then you're just sit and be quiet and observe. So if I turn it in, just leave it alone. Leave it alone, but pay attention if I have to answer questions. Yes. 5A. Anyone else have 5A that need help with? So yes? Okay, so 5A. 5A is the following diagram, which is an engine, which goes up to a pulley, which comes down to a thing that weighs 6 newtons, about 3 meters. The total amount of electrical energy used by the motor is 30 joules. So that's how much energy the machine is putting into the system, right? So that's how much the machine is putting into the system. So that means my work, you guys, there's some chatter. I'm going over the homework, so you don't want to pay attention. You guys good? Awesome. So the work in is 30 joules, and it's saying how much is being lost to heat. Well, don't forget, work is just the transfer of energy, and you can't really lose energy. We say lose to heat, but it really just goes to heat, right? So if the work in is on this side, we get out the work out, and heat and friction and sound, kind of, if you want to think of it like that. All of that goes on this side after the engine goes. Okay? So we have work in. We can calculate work out, and then we can find heat. So let's calculate work out. Work out, we have 6 newtons. That's a force, right? 3 meters. What quantity is that? Distance. Distance, thank you. So my, ooh, this brown is not working for me. So we have that. Work is force times distance. What's the work of the output?
18.
6. Oh yeah, 6 times 3. You guys were skipping a step on me, but that's awesome. 6 times 3, so that is 18 joules is my work out. So my work in is 30. My work out is 18. And I'm left with heat. How do I find heat?
Subtract 18.
Subtract 18 from both sides. Awesome. And what do I get?
12.
12 joules of heat loss. Does that make sense to those who didn't get it the first time around? The work has to go somewhere, but since all machines aren't that perfect, they're going to go into other things, right? Okay, we good? So we come around and pick them up. If you didn't already do then great. If not, you don't have it. Don't forget that sheet of paper that says why you don't. Start with here, in. Whoop, sorry. 6%, 60 is awesome. 60 or 0.6, they're both good. Both great answers, 1%, one's not, but they're the same. Okay, well, I'll help you. Why? Because the answers were right, you're going to get an efficiency of like 250%, and that's not technically actually correct. Not technically, it's not physically possible. It was poorly written. You work here today. Awesome sauce, awesome sauce.
You want me to write one of those? Awesome sauce.
I know, you're good. You're good. Your turn to yesterday? Awesome. I
So did I.
Okay, so yesterday we talked about, what did we talk about yesterday? What did we talk about yesterday? Simple machines. Yeah, something else we talked about yesterday. Efficiency. Mechanical advantage. That is awesome. Today we're going to extend our look on a mechanical advantage, and we're going to do that by doing a lab with pulleys. Does anyone remember what the equation for mechanical advantage is? You can look at your notes for this. This isn't a verbal pop quiz.
Output force over input force.
Awesome. Thank you, Jeff. So, my mechanical advantage is my output force divided by my input force. So, across the hall, we have all these different pulleys. Oh, and heads up, there's no handout for this. You want me to get your own sheet of paper and write down what I'm doing so you know what we're doing across the hall. So I'll let you guys do that really quickly. Heads up, Miss Crane didn't make copies today. So, this is the lab. Or we're over here in the lab. I'm like explaining it as we're going to do it. We have a lab today. Yes. Lab today, test on Thursday. Test on Thursday. Okay, so as you guys figure that out, I'm going to kind of go on. So across the hall we have all these different pulleys, right?
Right.
The input force is going to be what I pull on the pulley, right?
Right.
What do you guys think my output force is going to be?
When it goes up.
Oh, then it goes up, but what is that force going to be equal to? Maybe not, maybe not. So I use a pulley to lift something up, right?
Right.
What do you think I have to at least be equal to or more than to lift up something? The weight. The weight, awesome. Anna was right. My output force is going to be the weight of whatever I have attached to the pulley, which is its mass in kilograms times 9.81. There's a triple beam balance over there. It's going to give it to you guys in grams, and you're going to try to do grams times 9.81. I'm going to tell you right now it's not going to work. Okay? Got to be in kilograms. Okay. So we talked about what our input force is. Talk about what our output force is. I'm going to give you guys the goal for this lab. The goal for this lab is to find the relationship between mechanical advantage
Oh my God.
on silent. Thanks. Everyone else is on silent? Want that to happen again? Videotaping today? Awesome. Find the relationship between mechanical advantage and all my markers are dying. This crane needs to
Advantage in what?
mechanical advantage and awesome. The number of strings on a pulley. Now this is kind of confusing. I can't think of a better way to say this. You really only have one string. You can just loop it around the pulley different times. So really counting the loops, and when we get to the pulley, I'm going to show you exactly what I mean by what counts as 1, what counts as 2, what counts as 3. But that's kind of our goal.
I already know.
Awesome. Well, that's your hypothesis. Let's see if you're correct.
Well, you showed me yesterday.
Yeah, well, we'll figure it out. So, what you're going to do is you can set the pulleys that we have over there 4 ways. You can have 1 string, 2 strings, 3 strings, and 4 strings. You're going to find the work input for these setups, because we have spring scales, you can just use those. We're going to find the work output, which is just the weight of what you're lifting, should be the same every time. And the mechanical advantage is just the output over the input. When you found all those mechanical advantages, I want your group to write me 2 to 3 complete sentences about what the relationship is, what you found. So when we go next door and I show you guys how to set out the different pulleys, do you guys think you guys can handle it from there? Or do you guys have any more questions? Clear as mud?